Okay, today we're going to do a little bit more with area of a circle. So let's start off here, giving you the formula for area of a circle. It's pi times the radius squared. Pretty simple. We've talked about it a little bit before. Find the radius, square it, multiply it by pi. Okay, we're going to find the area of each one of these circles. Okay, so we're given that the radius is 5 centimeters here, for example, A. And they want us to use pi is equal to 3.14. So we'll do pi r squared here. We'll do 3.14 for pi, 5 for the radius squared. Okay, 5 squared is 25. And 25 times 3.14, 78.5 centimeters squared. And that's it. We're done. Okay, it's just order of operations. Once we know what pi is, and this is not exact, by the way, because 3.14 is an approximation of pi. And once we know what the radius is, we can figure out an approximation of the area. Now on B, they want us to express the area in terms of pi. And you would think this would be more difficult. It sounds a little bit confusing even, but I would actually argue that it's easier. So area of a circle is pi r squared. They're giving us that the radius is 15 centimeters. 15 squared is 225. So our area is 225 pi centimeters squared. Okay, this is the only way that we can express the area exactly. 225 pi centimeters squared. It's a little bit weird, but if we multiply it by 3.14 or 22/7, then we'll have an approximation of it. But it's about, it's exactly 225 pi centimeters squared. That's the area. What is the scale factor from the circle in A to the circle in B? The area of the circle in B is how many times the area of circle in A. Okay, so let's look at both screens here at the same time. The scale factor. Okay, we started with a radius of 5. It got bigger to 15, so 5 times 3 is 15, so the scale factor is 3. Okay, now as far as the area is concerned, 78 25 pi, I guess that's probably a better way to look at it. 25 pi times what is 225 pi? 9. So the area is actually 9 times bigger in circle B than circle A. Okay, we got 25 pi and 225 pi. Circle B is 9 times larger in area than circle A. By the way, 3 squared is equal to 9. The scale factor squared, just like area is units squared, is equal to 9. We've seen that stuff happen before when we were dealing with rectangles and squares. Okay, next, a 140-foot diameter helicopter landing pad covers an area of about how many square feet? And we need to pick which value of pi we're going to use, and we're going to choose it wisely. Since they're asking us about how many square feet, we can choose an approximation of pi. We don't have to use the exact value for pi. We're going to use 22/7 for pi instead of 3.14. And that's because the radius, 140, is divisible by 7. 7 here in the 22/7. So area is pi r squared. We'll use 22/7 times 140 squared. I'm sorry. Caught myself there. It's actually 70 squared. The diameter is 140, so the radius is 70. That's kind of stuff we got to watch out for. I even caught myself there. 70 squared is 490 or 4,900, which is divisible by 700 or 7. And then 22 times 700 is 15,400 square feet. Okay, so this time we didn't use 3.14. We didn't use the exact value of pi, the pi button on your calculator. We used 22/7. It's another good approximation of pi. If you do 22 divided by 7 on a calculator, it's about 3.14, about pi. All right, a semicircular window with a radius of 36 inches allows light through an area of how many square feet? We're going to use a calculator to get an approximation. We're going to round our answer to the nearest square foot. Okay, well, area is pi r squared for a circle, but this is not a circle. But we'll start here anyway. We're going to divide it by 2 because it's a half circle. Okay, so we can do that. So we're going to use pi times 36 squared over 2, which is 1,296. That's 36 squared. 1,296 divided by 2 is 648. And then on the calculator, we'll just do 648 pi. Comes out to a huge number here. 2,036 square feet. So I just used the pi button on the calculator, 648 times pi, which is approximately 648 times 3. But they said round our answer to the nearest square foot, so I did. All right, last thing, some more with area here. In the figure, segment AC is a diameter of circle O and measures 12 centimeters. I'm going to write that in here, 12 centimeters. Central angle BOC measures 60 degrees. I'm going to write that in. BOC is 60 degrees. That's this angle here. Obviously, we could figure out the other angles if we wanted to now that we know that. Find the area of the sectors named in F through H below and express each area in terms of pi. And again, expressing things in terms of pi should not freak us out. It actually, I would argue, just makes things a little bit easier. All right, so let's start here by finding the area of the entire circle. Area is pi r squared. So I'm going to do pi times 6 squared, because the radius is 6 if the diameter is 12. So the area is 36 centimeters, 36 pi centimeters squared. That's the area of the entire thing. They want to know sector BOC, which is just this little slice of pie over here. Okay. Here's how we'll do that. Sector BOC is 60 degrees, so it's 60 degrees out of 360 degrees. We'll multiply that by the area of the entire circle, and we'll find out what fraction of the entire circle is BOC. It's going to be 6 pi centimeters squared. Let me show you how I got that without a calculator. It would look like this. Let's see, 60 goes into 360 6 times, and then 6 goes into 36 6 times. So we end up with 6 pi centimeters squared. Continuing on. Sector BOA is this over here. Okay, well, the measure of that is 120 degrees. So it's 120 degrees. Sorry, I'm writing that in the wrong spot. 120 degrees out of 360 degrees. And again, we'll multiply it by the area of the entire circle. 120 goes into 360 3 times. 3 goes into 36 12 times. So it's 12 pi centimeters squared. Notice too that since the angle is twice as big, it's 120 compared to 60, the area is twice as big, 12 pi compared to 6 pi. And last one, sector AOC. That's this whole thing over here. It's half the circle, isn't it? Should be half the area. Maybe I'm making this a little bit more complicated than it is. 180 out of 360 degrees. 180 goes into 360 twice. 2 goes into 36 18 times. So it's 18 pi centimeters squared. the whole thing, the area of all three of these segments should add up to 36 pi. And it does. All right, so watch that again if you need to. Rewind it. That's all I've got for you today over the area circles. A little bit more complex than we've done with area in the past. And hopefully you'll find that it's not that big of an increase in workload for you. Have a great night.